welcome back to another Evolution Live. You should know that before each of these starts, I'm jigging along to the music, and every single time I am annoyed that when I first set this up, I wasn't able to do it so that the 90-second mark hits that change in the music where you get that extra small musical things. Hello, welcome back to the live stream, and this is the 7th Evolution Live, a live stream course where an hour a week I teach you people that previously didn't know anything about evolution, stuff about evolution. And I've decided that this will be the penultimate Evolution Live because, as I mentioned in a previous stream, Oxford terms are weird, they're only 8 weeks long. We will have had 8 weeks next week. I can't believe it. I can't believe this is 7 weeks of Evolution Live. We've come so far. And we've reached so high, and we've looked each day and night in the eye. It'll take that tune for you. Today we are doing phylogenies, or as I ominously titled it, the family tree of everything that ever lived. A quick recap for those of you that have not been here before, though by the looks of it, the people in the comments, you've all been here before, you all know the drill. I am Dr. Sally Page, I have a PhD in evolutionary biology, and here is a live stream where you get to learn about evolution. All of these will be available on my channel afterwards, so if there's anything you don't understand, you can go back and watch those ones. Intro music is out. Let's fade in the background music. And there we go. Now we're chill, audio levels are good. I'm, as always, doing this just from my office desk, controlling the comments, the audio, the video, the various webcams, the lesson plan, all by myself. So bear with if I get distracted. And yes, welcome everyone to the chat. It's nice to see some familiar faces. So last week on Evolution Live, my previously, we were looking at speciation, and so we've got so we learnt that a species, the definition for it, one definition of a species, but the one that everyone in the textbooks wants you to know, is that a species is a group of organisms that can reproduce to produce fertile offspring. And so with speciation, that's when two populations become reproductively isolated through various means, physical or behavioural means. And after this period of isolation, there are changes in the allele frequencies, which we know is the definition of evolution, changes in allele frequencies, to the extent that when they're brought back together, they can no longer interbreed and produce fertile offspring. And so we get speciation, and we create all of the species on the planet that have ever lived. And today we are going to be looking at the relationships between these species. So yes, there was a reason why I put the lessons in the order that they are. Each one builds on the last. So today, this is our lesson structure. And so we're going to be looking at relationships. The technical term is phylogenies. So phylogenies are is the study of evolutionary history, really. It's the study of the evolutionary relationships between species. So I suppose you start off, the underlying principle, not only of phylogenies, but of evolution itself, and kind of underpins the entirety of biology, is that we are all related. There we go. Back to my little pink animations. So we are all related, and I don't mean that in a kind of, oh, everyone holding hands around the world. No, literally, and by we all, I mean literally everything that has ever lived is related, because all organisms on Earth have evolved from a single common ancestor. And when you think about it, that's kind of a big deal, because it's one of those, everything you see, everything that has ever lived came from one shared common ancestor. And that needn't have been the case. It's quite possible that life could have arisen on Earth, and then maybe life formed independently on, say, I don't know, Mars, and then some of the Mars life and some of the Mars life moved over to Earth, and so we would have two groups. You'd be able to split all of the species from the ones that initially formed on Mars and the ones that initially formed on Earth. But we don't have that. We have all of life coming from one common ancestor. So let's go to the notebook. Can't believe it's number 7. Gosh. So where's my pen? There it is. Just think, you've only got 2 more weeks of looking at my dodgy digital handwriting and my inability to use the software even after 7 weeks. So all organisms have evolved from a single common ancestor. And we have various names for this, so we call it Luca, because biologists love a good name, and they looked through the list of baby names and they decided to call this single common ancestor Luca. Obviously it's not, it is lowest universal common ancestor. So this is the origin. This is the origin of species. This is the species 0 that everything came from. Of course, it doesn't necessarily have to be the first thing that ever lived, because if the first thing that ever lived only had one offspring, and that only had one offspring, and that only had one offspring, and then it branched out, then that 4th generation would still be the lowest common ancestor, lowest universal common ancestor. We also have Merca, not to be confused with MRSA, and that is the most recent common ancestor. And this is the one that we're usually most interested in. So this one is kind of like the first species, whereas the most recent common ancestor changes based on who you're looking at. So the most recent common ancestor of humans and chimpanzees will be different to the most recent common ancestor of humans and bananas, and we'll go into that this week. What else do I have? Oh yes, so we can look at the evolutionary history of groups to work out who is most closely related to whom. So all of phylogeny, I should say, this is what this is. So phylogeny is the subject, but you get phylogenetic trees. So phylogenetic being the adjective. So it is philo meaning tree and geny meaning genes. Where does the gen come? Life. Gen means life, right? Genetic. Genesis. Genesis is life. So it's trees. It is the study. Phylogeny is the study of evolutionary history. And you can either be looking at the history of all the things that ever lived, or phylogeny can also be quite recent things. So for example, the people that are looking at the C word, the disease that must not be named on YouTube for fear of demonetization. The ones that are looking at possible mutations and where it has derived from, so was it bats, was it pangolins and things like that. They're also looking at the phylogeny of that virus, as well as the people who are looking back all the way back in time beyond the dinosaurs back to single-celled organisms. That brings us on to common ancestry. This is like, what is it? Ancestry.com, but even more extreme. So when we think of ancestry, we think of things like ancestry.com. We think of our lineages and our relationships within our families. And so I think that's a really good place to start when you're thinking about evolutionary relationships, because by and large, it is the same rules and the same words that we use for describing human families, human family trees, as we do for phylogenetic trees. They're basically the same thing. So if I was to draw a hypothetical family tree, I'd pick someone like a character here, but I can't think of who would be a good person to pick. I don't know. Let's say you've got you. My hypothetical character here, you, and you have your sister, and the two of you come from your mum and your dad. And then I should have started this whole thing lower down. Oops. Bear with. Oh, silly thing. It behaves very differently if I use my pen versus if I use my mouse. Let's start this lower down. Okay. So, and then your mum has maybe your uncle, and your dad maybe has a sister, so that would be your aunt. And they come from your maternal granddad and your maternal granny. And these ones come from your paternal granddad and paternal grandma. And then maybe your uncle marries, and so to not get confused with aunt over here, I'm going to call this wife. And then you have a cousin, and maybe cousin has a husband, and you get your niece. Like, it's a family tree. We're used to family trees, right? And like all family trees, they're so big they don't fit onto a single page. Let's be honest, we don't really care about the husband on the left there, do we now? So this is a family tree. And this is something we're quite used to. But it still points out some quite important things. So, starting off with you. So you know that you are more closely related to your sister than you are to your cousin. And you're more related to either of them than you are to your... How is this going to work? Actually, I'm gonna add in an extra branch. Am I gonna add in an extra branch? No, that will get too confusing. But you know that you are more related to your sister than you are to your cousin. Like, You know that. You don't need a biologist to tell you that. But if we wanted to formalize that, we can look at, okay, so how can we see that that is the case on the tree? We know this is the case. We know you're more related to your siblings than you are to your cousins. But how do we show that on the tree? So we are looking for common ancestry. We want to go back in time to find the most recent common ancestor between the two of you. So if you go back in time from you get to your parents' generation. And if we go back from your sister, oh look. So we can say that the most recent common ancestor, oh God, that looks like your mum and dad had some terrible argument. The most recent common ancestor between you and your sister is here. It's your parents. Like, that is, you kind of understand that. Whereas, let's say we're looking at your cousin. To get from you to your cousin, you start at you. You have to go up. You've got to go through your mum's side of the family and all the way up to your maternal grandparents before you can start coming down through your uncle's side of the family to your cousin. So the most recent common ancestor between you and your cousin is a whole generation earlier. And so the most recent common ancestor was, your most recent ancestor was more recent for you and your sister than it was for you and your cousin. And that's basically another way of saying that you and your sister are more closely related than you and your cousin. And you can imagine that if on the other side of your family, that even further back, so when we say that everyone in Europe, say, is related, you've got to go back through so many generations before you can start coming down the family tree to someone else. And it's pretty much the same when we're looking at phylogenetic trees. So we've got here, while I'm on this, we could say that this is the branching point between your uncle's side of the family and your mum's side of the family. Because you can imagine, obviously trees normally grow up, but if we're looking at time coming down, then it will grow like that. But this is where there has been a branching and splitting off your cousin's family and your uncle's family from your family. But also, you and your sister branched off so that if you have a family and your sister has a family, their families will have most recently been together at your parents, and then everything after that is a branching point. So if you understand it with human, like actual family trees, you should be able to apply it to phylogenetic trees. So, team trees. This is not a team trees video, but we're going to be talking a lot about trees. So I thought I would do that anyway. So we can draw, just as we can draw the relationships between members of a human family on a tree, we can draw these same relationships for any species. And so the things that trees tell us, they give us an aspect of time. So imagine you're starting from the bottom and you're branching up. That's the progression of time in a tree. And they also give us the branching points, and those branching points give us those relationships between groups. And this is where I bring in my inordinate collection of chocolate bars, because you know me, if I can get chocolate into a video, I will. I will say that I am actually planning a video about the science of chocolate, which is why I have this one. I had all of these in my cupboard anyway. We're in quarantine, I get through a lot of chocolate. But we're going to imagine that each of these chocolate bars is a different species, And sorry if there's rustling on the microphone there. We're going to imagine each one is a species and see if we can work out what the tree is, so what the relationships are between them. Because that is basically someone's saying that they're jealous of the chocolate and blue chocolate. This is not all the chocolate I have in my cupboard. I also have like mini eggs and Twixes and things that weren't bars like this. You can see that this one is already open from when I have my chocolate pancakes in the morning. What can we say? There's no judgment here. So I am going to move over to table view. Okay, move my microphone out of the way a bit. Oh no, someone's just finished the chocolate at home. Oh, that's a disaster. Okay, so we've got contestant number 1 is classic Cadbury's Dairy Milk. This is the original and the best. We have Cadbury's Dark Milk. This is new. It's in the Cadbury's family, but I think it's like 40 or 50% cocoa rather than... Oh my god, Eric's just pointed out that I can therefore use this chocolate on expenses. That is such a good idea. If I hadn't already bought it, I should have put it through expenses so I didn't have to pay tax on it. Next time when I'm buying an inordinate amount of chocolate, I will. So Cadbury's Dark Milk, it's by Cadbury's. It's a bit like dairy milk, but with a higher cocoa percentage. Then we have Swiss Chocolate Milka, which is another milk chocolate. This one has hazelnuts in it. We have this one I splashed out because I managed to get an Ocado order, so I wanted to go fancy. This is 70% dark chocolate, but it also has raspberries in it. None of these companies are paying me, by the way, if only they were. And this I've never had. This is ruby chocolate. Also, what a lovely packet is this. It's got lovely parrots and everything on it. And a secretary bed, maybe? So ruby chocolate is supposedly the 4th type of chocolate after you've got white, milk, dark. Ruby is supposed to be the next one. It's based on how they ferment the beans before grinding them into chocolate. There'll be a video on this at some point when I get around to it in quarantine. Basically, once I've made the cushions for my table next door, because it's just foam at the moment, I need to sew up the cushions, then I'll make the video over there. Things I have to do in quarantine, but I've not tried this yet, so I have no idea what it tastes like, but I thought this was a nice selection of chocolates. So imagining that each of these is a species, and you're just presented with them in any order. I'm just gonna shuffle my chocolates, you know, they could come in any order. And the question is, I wish I could zoom out a bit on this, but I can't. The question is, how are these related? So who are the cousins in this group and who are the sisters in this group and things like that. So I'm gonna start with the classic dairy milk and say that this is basically everything that we're gonna base everything off this. This is gonna be our focal species for now. We could pick any of these species, but this is gonna be our focal. So, which of these do we think is most related, which of my other chocolates is most related to the Cadbury Dairy Milk? Well, I think it's fair to say that the other Cadbury's chocolate, they're obviously different species, but they're going to be pretty closely related. So I'm going to pop these here. The similarities between them are that they're literally both Cadbury's. They have the same name on them. They've got to be pretty similar. Okay, so now of these three we have left, the question is, which of these is most similar packaging style. Which of these is most similar to our Cadbury grouping? So imagine that these are brothers and sisters of each other. but then maybe one of these is the first cousin. So the things we know about it. So we've got Cadbury's, they're both purple. We've got one milk chocolate, one not quite milk chocolate, but not quite. Milka, we've got is milk chocolate and is purple. Divine, we've got black packaging, but it's also got gold writing on it. But it's got raspberries. Prestat is completely in a world of its own. So yeah, lots of you agreeing that Milka is going to be the cousin of these two. So I'm going to pop it, what side of the screen is it? That's on the left-hand side of the screen. So this is going to go here. Now, imagine these are the family group now. So we've got, this is our family group. So then what is the next one along? What is going to be the second cousin of this group? Is it going to be the dark chocolate, or is it going to be the ruby chocolate? So again, we've got, well, both of them have got gold packaging. These are now both in paper packaging rather than the plastic foil. I don't know what you'd call it. But I would say because the chocolate is brown, and this, I haven't opened it, but ruby chocolate, the chocolate inside is actually pink, in the same way that white chocolate is cream. Someone says I really need a white chocolate in there. I don't buy bars of white chocolate, and yeah, 5 is enough, as we'll get into. So yeah, I see some of you agreeing with me that I think this one would be next, because the chocolate is brown and it's the least out there, which means that then this, which is just completely unrelated to all of the other chocolates. I mean, who's even heard of ruby chocolate, right? So that will go at the very end. So what we can do is now draw this on a tree. So if I go back to the notebook, I, as always, have got my little pictures here. Bring them down. So what I should point out is, although in family trees, we usually have going back in time, going up the page. In evolutionary trees, phylogenetic trees, we normally have going back in time as going down the page. So we have our species, and I've ordered them in the same order that we ended up with on the table. Yeah, it's going to annoy me that they don't have transparent backgrounds. I don't know how to solve that on here. So, if I now have my pen. So what we said is that dairy and dark are most related to each other. And so we can say that they branched off most recently from each other. And then as a group, the two of them, so this point here, becomes the two branches. That is next related to Milka here. So we can then draw back like this, and we get another branching point here. And then the 3 of these all come from this one branching point here. And so this, sorry, I'm trying to read the comments and someone's like, how has she got the notebook frame? Well, snazzy little thing. It's nothing to do with notebook, it's just on OBS. There's a cropping, it's cropped in the window. I just wanted it to look nice. So dark chocolate has a common ancestor with all 3 of these groups. And then ruby chocolate, the weirdo that it is, comes here. And then everything else comes from this one. And maybe we have a complete oddball, and maybe we have, oh my goodness, there is a blackcap in my pond. There is a male blackcap having a bath in my pond. I've not even seen a blackcap in the garden, and now it's actually having a, oh, that's adorable. Sorry, animal distractions, you get used to it. Maybe there's something completely weird, like, I don't know, gummy bears. And that, actually I'm going to do that, that's off screen, so I'm not going to put that there. I'm going to put all, yeah, so candy. Do Americans call chocolate candy? I don't know. But jelly sweets, so gummy bears are completely different altogether. Now, let's see what this means. So we have, this is one grouping. And this is the Cadbury grouping. And then we can say that this is the milky, low cocoa content grouping. So within that green, low, less than 50% cocoa grouping, a subset of that is the Cadbury group. And so you can see how successively you can, depending on how far back you go, you end up including more and more of these things. But what's important to note is that this is not the only way that this tree can be drawn. And this confuses quite a lot of people. And you've got to imagine that you have, you know, like hanging mobiles, like you'll have hanging over a child's cot. And that each of these branches is a hanging bit of metal, and they are on a little rotating bit in the middle. So I could just as easily swap these two. Oops, no, I couldn't. Stop doing that. I don't want to include that bit. How do I just... She says she could just as easily do it, but we all know that my technical side is, on this software, is not great. Oh, stop it. Sorry, I just shouted into the microphone there. It's annoying me. Let me rub this out and see if that makes it easier. So, there we go. I can just as easily swap these two round. Imagine like the mobile is spinning on this axis here. And these are the identical, this is the same tree. So that relationship there, although I've swapped the order of them round, it is the same. So I could also draw it out in a completely different way. Let's imagine that we are looking at things. Let's take divine chocolate. Let's see if this works. So we can take divine chocolate and is that gonna work? Commutative and not associated. That's a great way of putting it. It's all about the relationships rather than necessarily how you actually smushed it down onto a page. I'm not going to do that. I don't think that's going to actually help. But you can see how maybe I could. So let's take just these three. That's going to make it easier. So I could say that Milka is over here. I'm just going to write it out. And that is over here, and then maybe there is a branching off point with dark milk, and then there is a branching off point with dairy milk. Like that. So you can choose kind of who, oops, that's off, who it goes to. Because, and I point this out because a lot of people, when they think, if you remember back to the Ascent of Man picture, a lot of people will see this as, imagine that dark milk is the be all and end all. Imagine that this is the lineage that you're following. And they'll be like, oh, well, then you've got everyone else is branching off from this lineage. And it looks like that. But of course, we could swap that round. And so it's not that dark milk is the pinnacle of evolution and everything else is branched off earlier. I could just as easily say that Milka is the pinnacle of evolution, like this, and that the Cadbury's branched off at an earlier point. So just something to bear in mind that way. Someone could either draw the dark milk. And there are many ways of drawing the same tree, but this is the tree, and we've based it on characteristics about the group. So we looked at the packaging, we looked at the colour, we looked at the flavour. So statistically, and I wrote this number down on a piece of paper that I've thrown to one side. Statistically, if you have one species, there is only one relationship between one species. Obviously, there's only one tree you can draw. Between two species, there's only one tree you can draw. Both of them share a common ancestor. With three species, there are three combinations. So assuming that they're all equal, you could say these two are a group and this one is separate. These two are a group and this one is separate. Or these two are a group and this one is separate. Once you add in a fourth, you have 15 possible trees. When you add in a fifth, you now have 105 possible chocolate trees. And if there were 50 bars of chocolate, so just think, there are millions of species on the planet. If you just looked at 50 of them, there would be 3 times 10 to the 76 possible trees. So if you knew nothing about the species and you were like, here are all of the options, all of the groupings, you would have 3 times 10 to the 76, which is a lot. And it is why phylogenetics is an entire field of study. So that is team trees. Now we have no such thing as a fish. No, I'm not talking about the QI podcast, although it does annoy me that people know about that and not about the actual thing. Or the really annoying people who are like, oh, you tell them a fact that you maybe read somewhere and they're like, oh, you just got that fact off QI, didn't you? It's like, no, I didn't. It's fine. I'm not bitter in the slightest. So we have a monophyla versus a paraphyla. So I'm going to go back to the notebook and I'm going to pick 3 of my species. Let's have ones with different names. So I'm going to pick these 3, and we said that it goes like this. So the purples are closely related and the divine is separate. So we've got, I'm just choosing them because the names, Milka, we've got Dairy Milk, and we've got Divine. And that's our tree, right? I'll vaguely mention other chocolate. If something is monophyletic, that means it is a single phylum. And that means that if we take Milka and Dairy Milk, and we trace back the most recent common ancestor, we get to this node here. So we call where branches break off a node. And if we take that node, so we've gone back to the node, if we now go back up in time and look at all of the ancestors of that, we get this grouping here. In fact, I'm going to draw on some extra chocolates here because we know we've got dark milk next to dairy milk. We've got divine. Maybe there's another type of divine chocolate here. Other milks, others branch off like this. I don't know, something like that. So if we take the most recent common ancestor of Milka and dairy milk, we come back to this node, and then if we go forward in time and take all of the group that come from this node, so now we're including dark milk as well, this is all of the descendants of the most recent common ancestor. So as a group, we call this a monophyla or a monophyletic group. If instead I wanted to include, let's say I wanted to include Milka and Divine because they're chocolate with non-chocolate bits in them. So Divine's got raspberries in them and Milka has got hazelnuts in it. If I wanted to treat that as a group, I would go back to the most recent common ancestor of the two and find something here. But you'll notice how in order to group together Milka and Divine, I have to exclude dark milk and dairy milk. So now my grouping looks like this, and I've got to cut out a section. Oh, it looks like a heart. I've got to cut out a section of the graph. And so we call this a paraphyla. Para meaning not quite real. Not quite real, or part of, like paramedics. They're not medics, they're slightly different too. Or a paraphyletic group. And why this is an important concept is that monophyla are more of a logical grouping in evolutionary terms, because we're looking at all of the descendants with the same relationship, because dark milk is just as related to Milka as dairy milk is to Milka. So to just look at or Divine is just as related to Milka as dairy milk is to Milka. And so it doesn't really make sense to exclude some of the members, even though they're all, it's like all of your cousins except the ones from that aunt and uncle. Like, it's causing you to say, except these lot. And so it doesn't really make sense as a group. And it just so happens that fish is the group. So you've got, so within your vertebrates, you've got your, I've got to draw, I didn't mean to draw this off the cuff. So we've got our reptiles, we've got our birds, they're a grouping, I know that. We've got, I think this is where it goes, we've got our mammals, we've got our amphibians, and I've drawn this wrong. There's another branch somewhere. I should have planned this out. I've done entire videos on the phylogenies of fish and fishes, because this isn't exactly how it works. Yes, it is. Yes, I am right. Okay, we're good. So we've got fish here. We've got because groups of fish. This is also fish. So say this is like sharks and this is bony fish. Ah, that's where it is, isn't it? Yeah. Because all of these have evolved bone. I'm off the picture. All of those have evolved bone, but we say that these are the fish. And so if you take fish, if you want to find the group between this and this, you go back to the most recent common ancestor. So that here is the original vertebrate. But then you're now excluding this whole group here. So these are the vertebrates that are not fish. So fish doesn't make sense as a group. That is why there is no such thing as a group. I can't believe I've only got 15 minutes left. It's all the chocolate, you know. That's what did it. So we have a hierarchy of groups. So we've been looking at these branches and I've been talking about this node, this ancestor, and this one, and this one. Well, very handily in biology, we have created names for all of these. They are dried king prawn curry or fat greasy sausages, which is of course not their real name, but it is a way of memorizing domain, kingdom, phylum, class, order, family, genus, species, which are the hierarchies. And each of these levels is called a taxa, and then, sorry, taxa is any grouping of animals, and within them you get classes or phyla or whatever. So how do I draw this? So we've got, imagine you've got, let's take humans. So we've got dried king prawn curry or fat greasy sausages. Katy Perry came over for great songs. Ah, that's a good one. Yeah, because it used to be king prawn curry and then we created domain quite recently. So domain, kingdom, phylum, class, order, family, genus, species. So domain is the big one, because remember that we're looking at trees like this. So the lower down the grouping, the more things it includes. And the higher up the grouping, the fewer things it includes. So domain, we only have 3. We've got the eubacteria, the archaebacteria, and everything else, which is the eukaryotes. Did King Philip come over for ginger snaps? Oh, that's a good one. Or King Philip came over for good soup. Ah, so did Katy Perry come over for great songs? You can come up with any of them, really. So our domain, it's like when you learned that your address was like, this is my address, this is my address in the UK, in England, in the UK, in Europe, in the world, in the solar system, in the Milky Way, in the Andromeda branch, in the universe, and you used to be able to write it out like that. We can do that with humans. So our species, we call it our species name, is Homo sapiens. And this is binomial nomenclature, binomial, 2 names, binom. So we have Homo is our genus and sapiens is our species. Because of course there are other types of Homo species. There's a Neanderthalis as well. So those both come off from Homo. And then our family is Hominidae. I always get them. So it's Hominidae. There's too many eyes in the human thing. But there were others that weren't Homo. Maybe they were, trying to think of a non-Homo genus group. It's not Pan. Pan's chimpanzee. Anyway, then the next one down is order. So for us, order is primates. Is it pan? That's going to really annoy me right now. Hang on. Hominidae. Who else is in hominidae? Yeah, pan and gorilla. So for example, gorilla would be another option here. Just so you can see what the different things are. Primates is our order. No, I was right. We are most closely related to chimpanzees and bonobos, and they are pan. So Homo and Pan are both genuses within the family Hominidae, and then Hominidae and something like Ponginae. So Pongo is one of the apes, gibbons, I think. They all have a similar name at the end, and so I am getting confused. I don't have time to get confused. So within primates, we are in the mammals, and of course there are loads of other types of mammals. We've got carnivores, for example. So primates and carnivores are on the same hierarchical level as each other. And then we are mammals within the phylum Chordate. So chordates are, I should say that's mammalia, anything with a backbone. So mammalia, we also have amphibia, we have reptilia, like all of these familiar names. So we've got in the kingdom Animalia, because we're animals, and then our domain is eukaryote, because we have cells that have organelles inside them. So yeah, chordate is basically vertebrate until you start looking at things like lampreys, which are chordates but not vertebrates. Or the lancelet, because their juvenile form has a spinal cord but doesn't have a backbone. Yeah, so it's basically the same thing. I think vertebrate is a super class. It's like even higher. So you can break it down however you want. And then within each group, these are mutually exclusive. You cannot be both a primate and a carnivore. You can only be one. And those are the taxa. And yeah, if you want more information about all these relationships, I made a video called Fantastic Fish and Where to Find Them, which goes through all of the invertebrate ones, because we think we're really special as humans. But if you think that our phylum is chordate, other phyla include all of the mollusks, that's one, all of the hexapods, so anything with 6 legs, that's one, corals, that's one, sponges, that's one. So all of vertebrates is the same hierarchical level as all the sponges, just to give you an idea of balance. So those are the hierarchies. Now finally, what I think is the most interesting part of this is that we have evidence for making trees. We use evidence to draw the relationships between these trees. But once we've found out the relationships, we can then get evidence from the trees. So we make these phylogenies based off data about the species. So maybe, like when we were looking at our chocolate, we looked at the morphology, we looked at the colour, the shape, the packaging, what it looks like now. So that would kind of be the anatomy, just as we can look at a ladybird and a stag beetle and say they look more similar to each other than either of them do to a tiger. because both of them are beetles and a tiger is a mammal. So that's kind of anatomy and morphology. We also have fossils. So we can actually look back in time and see, oh yeah, we have found Tiktaalik, which is the common ancestor, kind of all of the four-legged land animals, the tetrapods. And so we can look at all of the tetrapods and say, actually, we know what their most common ancestor looks like because we have a fossil of it. We also now have DNA sequence data, which is by far and away just like blown open phylogeny and the genetic field. Genealogy, that's the word I was looking for earlier. Genealogy is to humans what phylogeny is to all of life. So with DNA sequence data, we can actually say, if you've got the code AAAAA and AAAAT and CGATC, those first two are more similar to each other than either of them are to the last one. So we use that, we take something that is shared across all of them, so commonly that's ribosomes, which make proteins, because pretty much everything has a ribosome, and they all started off with the same ribosome, and so we can compare how the mutations have changed it. So we get our trees, but then once we've got these trees, we can go back and say, well, what does this tree now tell us? So if I go back to our chocolate tree, so maybe based on anatomy or DNA evidence, we've got this tree here. But we can say, okay, now we've got this tree, we can say that chocolate, if this is all the chocolates that there are, and these gummy bears are in a different group altogether, we can say that the original chocolate broke off from all of the other non-chocolate sweets at this point. This was the branch point for where this was the evolution of chocolate. Because before that, we had candy. But at this point, chocolate broke off from all of the other jelly sweets. And so now we know that chocolate only evolved once, and we've got a good idea of how far back in time it was as well. Because if we know this fossil here, and we know that this fossil was 100 million years old, because we found it, we know that chocolate evolved before 100 million years ago, like longer, more than 100 million years ago. But now we can also say, okay, so let's look at milk chocolate, because remember when we were trying to organise these three, we were like, well, do we group these two together because they're both milk chocolate, or do we group these two together because they're both Cadbury's? Well, using multiple lines of evidence, using DNA, using anatomy, all of that, we decided that dark milk and Cadbury are more closely related than either of them are to Milka. But that means that because we've got, this is a milk chocolate here, but this is a milk chocolate here. So either this is the common ancestor of these two. I realise this is getting quite messy, but this is the common ancestor here. Most recent common ancestor. Either this was a milk chocolate and something happened at this point so that dark milk evolved dark, or this was a dark chocolate and it evolved twice. This is where we often use the most parsimonious tree, the one which requires the fewest steps or changes. So we'll say that this is a milk chocolate ancestor because, otherwise we would have to say if it was dark and then you had an evolution of milk here and then you had an evolution of milk there, that's 2 evolutions versus 1 evolution. So we'll say that this was a milk chocolate most recent common ancestor. But this is a dark chocolate and this is a dark chocolate. So if we look at the most common recent ancestor for those, that comes down to here. But we know that this was a milk chocolate ancestor. So on this side is milk and on this side is dark. So actually, by knowing the tree, we can say that dark evolved somewhere along this branch. At some point, it evolved the adaptation to be dark. Maybe there was a selection pressure for higher cocoa content here. But then there was also the evolution for dark over here. So we can say that the adaptation for dark chocolate evolved twice independently. We had convergent evolution, two groups of the tree independently stumbled across the same solution to their natural selection problem. And now we know that these two things evolved independently. We can say, okay, that means that we've got something happened at this point in time here on this branch of the tree, and something happened at this branch here at this point in time that caused them to change to become dark chocolate. So what are the similarities between these group of animals at this time and these group of animals at this earlier time? And now we can be like, oh, so what are the shared conditions? So what is it that is likely to cause them or influence them to become dark? What are the shared selective pressures that mean that they're both likely to take this route? Someone very sensibly says, why is one more parsimonious than the other? Yeah, you're right. It could go either way. And in fact, that's exactly what happens in biology. You're like, there are these two things, but how do we know which one's more likely than the other? I mean, I'm assuming here that I'm simplifying the tree and that there's another dark chocolate here and another dark chocolate here. And maybe there's another milk chocolate here, like Cadbury Twirl, something as a milk chocolate here. In which case, it's starting off as a milk common ancestor and then evolving twice would be more parsimonious, but it could be the other way around. But often, like I said, we can have multiple different options, and sometimes the evidence is contradictory. You're like, well, these two are both dark, but this one's both milk, or these ones are both Cadbury's, this one's both milk. So you have multiple options of which tree is correct, and you just don't know. And they do lots and lots of computer modelling to try and work out which one is the most likely to have been the case. And you therefore create these trees literally with statistical uncertainties attached to them. So if you look in actual trees, not actual trees, actual phylogenetic trees, you'll see like numbers written on them. Like at each branch point, you might be like 0.9. So you're 90% confident that this was what happened at this point. But there's a chance that it was like something else. And yeah, there is a whole field of study which is all about that. But for example, we know that so all of the common ancestors that have lungs and legs, so the modern tetrapods, the birds, amphibians, reptiles, and mammals, all share a common ancestor, but that common ancestor hadn't actually made it out of the water yet. And so because we've worked out the relationships between these groups, we're able to work out that the evolution of land legs and air-breathing lungs evolved before the animals moved onto land. Therefore, there must have been some evolutionary advantage to having legs and air-breathing lungs whilst you were still in the water. And we think it's because in brackish water, where it's really salty and maybe it dries out a lot, it's actually quite good to be able to wade through swampy mud, even if you can't go on land. And breathing air, maybe there's very little oxygen in the water itself, so it's quite handy to be able to get some extra oxygen in, even though you're still primarily in the water and not on land. So we get information that tells you how to build the trees, but once we've built the trees, we can also get information back from it. That is the final point for today. Once again, thank you so much to the people who are supporting me on Patreon. I love you all so much. You are the major source of income for me right now. So obviously these courses are free, but I did want to say thank you to you lovely people. You are the ones who are able to keep me replete in chocolate. So thank you. Next week is going to be the final Evolution Live. It's going to be on the evidence for evolution because, unfortunately, evolution is seen in some circles to be a controversial topic. Obviously, I don't agree with that, but I think it's important to talk about the overwhelming amount of evidence for evolution. And so at the end of that as well, I'll probably spend about 40 minutes on the evidence for evolution. I will be answering any of your questions. You lovely people who have been following along, and maybe I didn't explain something very well, or you want to go a little bit further into one of the topics that I've covered. So write your comments, your questions in the comments, probably in the actual comments rather than like the live chat comments, just so it's easier for me to keep track of them once this is over. And I will answer some of your questions at the end of next week to kind of wrap up. That will be the office hours. Is that what they call them in the States? Yeah, you can come up to it's like come up to me at the end of the lecture and I'll answer any questions that you've got. So put your questions in the comments and I'll answer them next week. Have a lovely week. I am going to see if I can find out where that black kappa's got to, and all that remains is for me to slowly fade up the music and have a little boogie for the last 60 seconds. So, bye!